On this bottom portion, yes, bring it up here. On this bottom portion, I just wanted to go over real quick what happens if your pH is not a nice, neat number. So I'm going to, off to the side, do some really similar problems where you have to actually use your calculator and not just go based on the pattern. So the first thing I want you to write, First thing I want you to write is, let's say your pH is 13.6. And I'm asking you for the same thing that I was here. So I'm basically just going again. If your pH is 13.6 and you need to calculate your hydrogen ion concentration, so pH of 13.6, blank is your hydrogen ion concentration. The way that you'll actually go about calculating this is plugging it into that equation, which we technically did here, but here we noticed the pattern where you could just pull your exponent, whereas here it's not going to be that straightforward. So make sure that you know how to plug it in. So on that, if I have my 10 to the power of negative 13.6, then my answer is something way less neat than what it was. So 2.511, and I would round it to the same number of decimal places, or the same number of sig figs, sorry. So 13.6, I would round that to 2.51. So 2.51 times 10 to the negative 14th. So I'm going to write that. 2.51 times 10 to the negative 14th. So just keep in mind that it's not always going to give you a nice, neat number. And then we're also going to move on to the back page. Shh. Stick with me for a little bit longer. It says, what happens if you only get the amount of hydroxide ions? So if you are given only your OH concentration, then you are going to use the ionization constant of water from the formula chart. So we will give you this on your test. So your ionization constant is your kW of water, and that is given as 1.0 times 10 to the negative 14th power. That came out kind of ugly, sorry. So 1.0 times 10 to the negative 14th, and the formula that we're going to use this with most often is going to be that the ionization constant of water, or 1.0 times 10 to the negative 14th, is equivalent to the hydrogen ion concentration, or the hydronium ion concentration, times your hydroxide ion concentration. And then I want you all to keep in mind properties of exponents that you have learned before. Something that we kind of gloss over in this class because we haven't used exponents a whole lot before is when you are multiplying and dividing exponents that have the same base, what you do with the actual exponents. So the reason I'm bringing this up is because we know, this one says calculate the OH concentration for a solution with a hydrogen ion concentration of this. If I am given my hydrogen ion concentration and I'm looking for my hydroxide ion concentration, I can rearrange my equation to be solving for the hydroxide ion concentration. So what I can do is set up that 1.0 times 10 to the negative 14th, which is my kW. I would divide this right-hand side of my equation by the hydrogen ion concentration, and then divide this side. So divide that by 1 times 10 to the negative 8th, and that would equal my hydroxide ion concentration. If I'm doing 1 divided by 1, that's just going to cancel out, be 1, it doesn't really matter. 10 to the power of negative 14 divided by 10 to the power of negative 8. If I am dividing exponents, or dividing things that have exponents that are on the same base, I subtract those exponents. So what we're effectively doing is we're taking 14 minus a negative 8, and that will equal my hydroxide ion concentration.
Well, that would be negative 14.
22.
Negative 14.
No, it's negative 14 plus negative.
Which is negative 14 plus 8, which is 6.
Okay, sure. Negative 14 minus.
Which is plus, which negative 14.
Now y'all are confusing me again with this. Holy cow. All right, don't make it too complicated.
So you, at first you wrote 14
Well, but you said
minus
10 to the power
negative 8,
10.
which
Is it
would
10
be
to the power
14
negative
plus
14 or is it 10 to the power 14? Which one?
Negative 14.
Okay, so
Okay, so
negative
then,
14
negative
minus
14.
minus 8, which is the same
minus
thing.
negative.
Do you know
Okay.
how to have the answers to the notes like somewhere?
Don't make
I'm making it up as I go. Thank you very much. All right.
Wow.
Okay, negative 14 minus
Minus 8.
negative 8. Is that not what I wrote? I think I just dropped the negative. Okay, I think I dropped the negative. That's what happened. Sorry. Okay, thank you. Sheesh, now you guys got me all nervous. All right. Negative 14 minus a minus 8. What I was trying to get was that this is going to be a positive overall right there. So you're basically adding this. What you end up with is a negative 6. And now you've got me questioning if I'm even supposed to be doing the concentration on this. Basically, you end up with a negative 6. The whole purpose of this is that there's kind of a shortcut, which is that your pH value plus your pOH value are going to add up to 14. So if this is my hydrogen ion concentration, what is my pH? My pH would be 8, which means that my pOH would be 6. Okay, there we go.
So,
If we calculate our hydroxide ion concentration, now I'm all over the place. If I put this as a decimal, it would be 0. And then 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then a 1. My hydroxide ion concentration is going to be 1 times 10 to the negative 6th. I think I wasn't supposed to cancel out the 1 times something something. If I put that into decimal form, it would be 0.12345. My pH we already decided is 8, which would make it a weak base. My pOH, it doesn't ask for specifically, but I want y'all to know it, would be 6, because your pH plus your pOH equals 14.
that would be a weak acid.
I think we're done on this.
So that would be a weak acid.
No, it's a weak base.
No,
the
the-
pH is higher than the pOH.
Is this the one we're going to be doing whenever we have stuff?
No, I'm saying-
You will have a practice thing with this, so kind of, and then you'll learn titrations as well.
Can we call it a day?
You can.
15.
Slacker. All right, let's keep going. We have like 4 more things. Okay. No, we can do all of them, and you can get off my back. Thank you very much. Calculate the pH and the hydronium ion concentration if the hydroxide ion concentration is equal to 1.0 times 10 to the negative 3 molar. So first it says put the OH concentration in a decimal form. This should be second nature at this point. If I have the OH concentration given to me in scientific notation, to write it as a decimal, it would just be 0. What?
0.0001.
No, just 2 zeros.
Good. 0,
0, 0, 1.
Yeah, 0.
This is the same thing we thought about a second ago.
That's what he said. 0.00.
No, 0.001. 2 zeros. Okay. Thank God. Next part. You guys. I'm going to go ahead and just show the work with this again because I don't want my only example to be one that I messed up. So if I pull my ionization constant of water, which is 1.0 times 10 to the negative 14th, 1.0 times 10 to the negative 14th power. And that is equal to my hydrogen ion concentration, which is not given to me, so that's what I'm solving for, or I can call it my H3O plus, my hydronium ion concentration, times my hydroxide ion concentration, which is this, 1.0 times 10 to the negative 3. I need to get this by itself to solve for it, so I would divide this by 1.0 times 10 to the negative 3. Then that cancels out. I would divide this by 1.0 times 10 to the negative 3. And then I think what I messed up initially was that the 1 and the 1, I guess, shouldn't cancel out. And we'll just treat that as a whole number. So if I have the negative 14 minus the negative 3, aka plus the 3, my new number is going to be 1.0 times 10 to the power of what? Negative 11, which is my hydronium ion concentration, H3O plus, which is the same thing as my hydrogen ion concentration. So I'm going to put that number 1.0 times 10 to the negative 11th. If I put that in a decimal format, the number of zeros that would come after the decimal, so remember your leading zero never counts, but the number of zeros that comes after the decimal would be 10. So it's going to be 1 less than my negative exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a 1. Issues with that? Are we good? Cool. And then your pH. If your exponent is this negative 11, what is your pH? Just 11. If you're not sure, remember that you can plug that into the equation that we learned on the previous page, which was that your hydrogen ion concentration, that is equal to 10 to the negative pH. If you have a pH of 11, are you an acid, a base, or neutral? Base. Notice, I think this was maybe your confusion, Sean, is if you have a pH of 8 and we called you a weak base, then we labeled the pOH. These numbers, the pOH number does not tell you on your pH scale if it's an acid or a base. So they will always just add up to 14, meaning as one goes up, the other will go down. So if you want to, on like your test or quiz or whatever, you can label it 1, 2, I'm going to do red and blue.
I think I figured it out.
This actually really helps some students, so not just for you, but for people in general. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They pair up so that if you have a pH of 0, your pOH would be 14, and then 13, and then 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So the blue would be your pOH, and the red is your pH. So that is how they will be paired every time. Similar to what we talked about at the very beginning, they won't always be in these nice, neat little things, so you need to be able to calculate them with numbers like what we practiced like this. Like your pH doesn't have to be just a whole number like what we're giving. Number 3 says calculate the hydrogen ion concentration and the pH for a solution with a hydroxide ion concentration of 1 times 10 to the negative 5th. So if I have my ionization constant of 1.0 times 10 to the negative 14th equals my hydrogen ion concentration that is not given to me times my hydroxide ion concentration of that, so 1 times 10 to the negative 5th. I would divide by 1 times 10 to the negative 5th. Those will cancel. Divide by 1 times 10 to the negative 5th. So then I have negative 14 minus a negative 5. Negative 9. So 1 times 10 to the negative 9th equals my hydrogen ion concentration. I'm going to write this like that first. So 1 times 10 to the negative 9th. But then it says put it in a decimal form, so I need how many zeros after my decimal? 1, 2, 3, 4, 5, 6, 7, 8, and then a 1. Your unit is still molarity, or molar. Put the hydroxide ion concentration into a decimal form. I would need how many zeros after my decimal?
4.
1, 2, 3, 4. So calculate the hydrogen ion concentration, good, and the pH. There's not a spot to write that, but let's do pH. So pH equals what in this case?
14.
No, 9.
My pH is what?
Oh, sorry, I was thinking of the next one.
9.
Oh, that was 9.
My pH is 9, which would tell me that this is a base. Good. So we don't use the pOH scale to tell us acids versus bases. We only use the pH. Technically, I guess they could both tell you that, but it's like backwards. And so instead of memorizing it two ways and confusing you, we just use the one. Calculate the pH and the hydroxide ion concentration if the hydrogen ion concentration is this. So if I have 1.0 times 10 to the power of 0, first of all, what is my pH? Can you tell just by looking at it?
Well, 14. Yeah, 14.
My pH is,
0. It's 0.
y'all are just guessing at this point. If you're not sure, use your,
It's scrambled right now.
I know, y'all are scrambling my mind. Okay, your hydrogen ion concentration is going to equal 10 to the negative pH. So if you're not sure, plug that into your calculator. If I'm solving for pH, then I can put that there. I can say 1.0 times 10 to the 0 power equals 10 to the negative pH. Or, that's not even the equation I would use. Why did I pick that one?
0.
You are scrambling my brain. Negative log, that's my fault, of the hydrogen ion concentration. So you'd plug into your calculator the negative log of 1.0 times 10 to the 0. So if you have your equations and actually know how to plug them in, you're not going to get confused on this stuff. I think what's confusing is that these are all so simple you can do them in your mind. So your pH is what?
0.
0. Okay, thank goodness. Your pH is 0, which means that your OH concentration is going to be what?
Very low.
Which is?
14.
It's 14.
Well, 0.
Yeah, because they have to add up to 14. So how else would it add up to 14?
Yeah, your POH is 14, yes.
Yeah.
POH is 14, yes. But if your POH is 14, how would I write the concentration? So if it's in this, like in brackets like that, it's asking for the concentration.
So 0.13.
0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then a 1.
Next one is just 1.0.
This one?
Yeah.
Easy enough.
Sure.
All right, very, very last thing. Calculate the hydronium ion concentration and the hydroxide ion concentration for a solution with a pH of 1. So the pH is 1. You know the POH equals what? 13. Put the hydrogen ion concentration in a decimal. So here's where I'd actually use that. So your hydrogen ion concentration equals 10 to the negative pH. My pH is 1.
So just be 0.1.
Good. And the OH concentration
Is 0.12 and then 1.
0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then a 1. Thank goodness. I'm sure there were mistakes in here, so if you caught them, oh well. Don't forget to do your practice. The practice has much more realistic questions that are similar to what you'll see on the test.